Hi, this is Doug Vogt from the Diehold Foundation again. This lesson 1F will cover subatomic particles, how they came about in nuclear physics, and the theory of multidimensional reality's interpretation of it, and how to solve the problem that they have right now, which is way too many subatomic particles trying to figure out a bunch of tracks in these bubble chambers and cyclotrons. Anyway, so we'll start in. I'll be covering subjects that were covered in a Judgement. That's about 11 years ago that I wrote this book. And this is a more recent one that's about 2 years back. And so we're going to do chapter 3 on this book and chapter 2 on this, parts of it. About 2 weeks before I did my first video, Stephen Hawking had written his last paper. I have the copy of the paper. And what was interesting about it is he basically is saying the universe is the product of a hologram, or is a hologram. And I included a couple of quotes from the paper. In this paper, we put forward a new quantum cosmological model of scalar field driven by eternal inflation by using gauge gravity duality. Boy, that's a mouthful. What he's saying here with eternal inflation is the issue of, is the universe expanding? So it's an infinite expansion. And there's a couple of problems with that, basically entropy, but I'm going to cover that in the next video, 1G, on the astrophysics issues. Anyway, the other quote was, we show the resulting two-dimensional holographic measure in figure 3, which I'm not going to show. This yields a holographic measure on the global structure of such eternally inflating universes, or continually expanding universe. The application of our ideas is to more realistic cosmologies requires further development of holographic cosmology. In order to have a hologram, which is basically right now 2 reference beams, creates a hologram, you have to have information that creates the hologram. So he kind of got to a second dimension, a 2-dimensional, but he's really thinking of the 2 reference beams that creates the hologram. Not what I'm thinking, which is, I'm defining it as a transmission dimension. And you got to have a first dimension where the information is that creates the hologram. So I don't know why he didn't go all the way. Maybe over time, if he had lived longer, he might have figured it out. Over the last 5+ years, I've seen more and more physicists that are coming to the idea that, gee, maybe we are in a hologram, or reality seems to be like a hologram. And you're going to find out why with the subatomic particles and what they're doing. Okay, a little bit of the history of subatomic particles. Before the proton was first discovered in the late 1800s, the one who invented the first tool they could use is it's called a cloud chamber, and it was invented by Charles Thomson in 1911. Now, he had built this thing. It's basically either use alcohol or water, and basically he wanted to study the creation of clouds. But the byproduct of it was he had a tool by which he could see cosmic rays going through it, and you see a track, and sometimes it would hit an atom of water or alcohol, and you'd see more than one track. So the physicists glopped onto it and said, this is a great tool by which we can go study the interior of the atom, which is right. Anyway, that was the first stage. Then the bubble chamber was created. This one was Fermi's, and this track was done on this machine here, 15 feet in diameter. And again, it's a liquid, various liquids under pressure. And what you're seeing here, they'll take an atomic bullet and a proton. They'll hit a target. And what they see is these various tracks, and they made interpretations mathematically of all these tracks. And you see this one here where it goes in a circle. Remember when I said in video 1C about the dimensions and how matter comes into this dimension? And this is the model. Basically, the information that comes in to create the atom is going in a toroid design anyway, so once you impart a voltage high enough that the information can no longer exist in this time and space, it demodulates. But it goes in all different directions, really. And even though this shows it like this, but really it's coming in, the information is like coming in all 360 degrees in that point. The atom is created when it crosses the x-axis, which is there, or in the middle there, where these two wires come together. That's when it creates the atom. And anyway, you'll see an example, a better one. Here's another one. You see the curlicue here of these tracks? This shows it much, much better. The reason why these tracks are doing that, because they still have the information coming from the Diehold, the computer that contains this information, still has this pattern until it just disappears. Then, after they realized if they raise the voltage on these things, or the speed at which they hit one atom with another, it's the equivalent voltage, they'll get more tracks. Well, they did with CERN. In Switzerland, they got this stuff, and they're trying to make sense out of all these tracks. Good luck on that one. You see it curves, many of them curve, but they're hitting it with tremendous force now. Now, I'm told that, and what I've read also, most of the atomic bullets they're using is lead, and sometimes they use gold also. They want a nice big atom. They don't want to miss. But you can see this chaos. This is thousands of tracks. Each one represents a piece of information that made up lead or whatever that target was they had. Okay, let's go to basics. We're going to test one thing, one part of their theory. Is there, in fact, protons and neutrons in the center of an atom? Now, you have the center here, and then you have this cloud of electrons buzzing around based on the atomic number of the element. But again, by their theories, you must have the proton and the neutron in the same thing in the area. This is a picture of a hydrogen atom, which I've shown in the previous video. And what's going on here is a lot of the information that makes up the hydrogen directed to that point in time and space. And I'm going to show you the conclusion to this. You don't have a proton and a neutron going on here. You've got a center modulation point. And this cloud here is the static field that this information creates around it. Here's another example, maybe a little better to understand. Here's the center. Now they measure this stuff. This is picometers. A pico is a trillionth of a meter. But the way they measured it, sometimes this here would be a nanometer, which is a billionth of a meter. And also they measure it in angstrom units, which is 10 billionth of a meter. And I'll go through it. So anyway, you have the atom here, and it creates this cloud of electrons around it. Here's much heavier elements, xenon and radon. And you'll see in the center is the center modulation point, or as they think, protons and neutrons. And it creates this electron shells around it. Now I say it's just like the Earth has a center modulation point in the center, and the DE, F1, and F2 layers in the ionosphere is created by this, whatever's going on in the center of the Earth, electrostatic fields it's creating. Here, more of the traditional, we can call it traditional anymore, atomic idea. They created the idea of quarks. You have two up quarks and one down quark creates a proton, and an up and a down to create a neutron. This was supposedly created. The neutron was discovered in 1932, not with quarks, and the proton was 1886. This is supposedly the first cloud chamber evidence of a neutron. Just leaves a path like that. Here's a gold atom, and showing the center and the traditional electron shells around it, totaling 79 electrons, matching supposedly the protons in here. Now, we're going to test if their basic theory is remotely correct. What this table is the traditional scale of periodic chart. Over here is the measurement in angstrom units. Each one of the black squares are an angstrom unit, and there's a total of 10 angstrom units. And they have several ways of measuring. It's like 4 or 5 different ways. The crystallographers have one way, and the physicists have another way of measuring the core, where the neutrons and protons are in the center. You'll notice inconsistency. You've got lighter elements that are larger than much heavier elements. Now I'm going to go through and show you some of this to see if their theory is even right about protons and neutrons. Here, for some reason I like numbers better. It tells a better story. So, logically, it's a hydrogen, it's supposed to be 1 or 2, either 1 proton or a proton or a neutron. It's going to be 1 or 2. Helium has got 2 protons, 2 neutrons. This is 4. You know, you take this number and multiply by 2, and you've got it. So you've got helium with 0.949 angstrom units for a diameter of the core, where the atoms are. But lithium, with just 2 more, a proton or neutron more, it's 3 times the size. Does that make any sense? So you go on through this thing. Here's potassium, 2.27 angstrom units in diameter, the protons and neutrons in the center. And you go down to, let's say here, thorium has 180 protons and neutrons in the core. It's 1.8. It's less than this at 38. I mean, it's ridiculous. You get down to uranium, 184 protons and neutrons, and they say the diameter of the core is 1.75 angstrom units. Back to potassium is 2.27 or 2.47 for rubidium. I mean, even take here. Iodine is 1.33. Xenon is 1.3 in the center. Next to it, cesium, the 110 protons and neutrons is 2.65. That's double size. Now they can't say the proton and neutron change size. No, that can't happen. Not when you say they're up quarks and down quarks. You can't. Obviously, this theory that there's protons and neutrons in the center of the atom is obviously wrong by their own measurements. Somehow they seem to have forgotten that, or it's just left off in the wilderness and they forget about it. Okay, let's try to make some sense out of this thing. Theory of multidimensional reality explanation. My famous graph. This is time. This is the carrier wave that carries those thousands of pieces of information that makes up the elements. Not just a few hundred or something like that. So when it crosses the x-axis, it creates, identified this as the equivalent of Planck's constant, but it's our atom. There's our atom. And let's say when it crosses, does 180 degrees, it creates a neutron. Let's say this is a proton, that's a neutron. The key part here is this. You only have one atom in the center at any one time, because they can't. It creates it, let's say a positive, and that's negative or neutral, and they don't exist at the same time, do they? So what they really then want to say is that the information is being directed to that point in time and space, and sometimes the information appears positive and sometimes it's negative. And it's based on this. If this is Planck's constant, which is 5.39 times 10 to the minus 44 seconds, which we can't even measure, it's more theoretical. Who knows if it's right? We'll just accept it as being right now. Again, that information, and there's, I'm sure, thousands. Remember, in the previous video on light 1A, I showed iron had 4,169 spectral lines. That means everything heavier than is probably at least that many, or if not more. And there's a reason why we can't wind up seeing them, and I explained there is basically you can't assume that the carrier wave is coming into this dimension or is being transmitted at the exact same frequencies as all the others for the elements. It didn't make any sense to put all the elements into one carrier wave. It wouldn't work, it wouldn't be efficient, and we'd see something totally different. Anyway, as the thing crosses the x-axis, where I have the red line here is where it bursts out the information. So you've got proton, neutron, however you want to look at it, but it's only one element at one time. But is it really matter? Remember, this is basically a big hologram. So the hologram, when this thing comes into the dimension, the information itself creates this electrostatic field, which is, in essence, you could look at it as the second dimension. That's why it's able to transmit energy to another element, is because it's in the second dimension. I had the same graph in the previous video on light. What I'm saying with the carrier wave for any one of the elements probably don't come at exactly the same point. They probably vary in here. I just don't know, and we're too primitive to know where it's coming in. When I do the video, which is going to be the next ones after the video 1 series on the Hebrew alphabet, you'll understand why the carrier wave and stuff like that. Anyway, I think we're looking at here lower harmonics. I don't know if there's 2 above it or only 1 here and then 1 here. But I think this purple area shifts, like iron obviously filled up a good chunk of this right here. And then the other ones are shifted around here, like acetane can't possibly have only 2 spectral lines. It can't be, and the thing is a lot heavier. It's probably way up here, but we don't see it. We only see a little piece of it. Here's an example. This is the spectral lines I was referring to. I took a sampling here, and you can see it's all over the place. And there's just no way that something as heavy as californium 98, which got 96 protons and neutrons, only have 14 spectral lines. It doesn't make any sense. And one that's a little bit lighter, uranium, has 992. It's all over the place. You can tell right after, here's 1,020 spectral lines for tungsten, but something here, tellurium, 153. It doesn't make any sense. So obviously, something's being shifted over. What I'd like some physicists to do is take the spectral lines we do have of the elements and shift them over one another and see if the pattern works out. That's the key part. Is there a pattern to the spacing between the spectral lines? That may tell us a lot about how these elements work and families they're in. Here's an example, courtesy of IBM, of a light-based computer. This would be like in the Diehold, the computer itself, creates the digital data. Goes in here, this would be the part of the Diehold that I said acts like our video card. It assembles the information from a computer and then it transmits it at a lower frequency. This is where that work would be done. This is the transmission dimension. When it crosses the x-axis, it bursts out. Here's your light spectrum, or the information that makes that atom. That's how it would work. You see, man's inventions are decent analogies of how our universe really does work. Here's the study of subatomic particles. Again, this was their idea of a proton through a bubble chamber. And this is guesswork. This is a delta ray. They really don't know. Low energy electrons, they have no idea what these things are. It's most guesswork. High energy electron or a muon. They don't know. It's just guesswork. It's what I call mathematical magical thinking. A friend of mine, Barbara, came up with the idea of magical thinking. That was for the rabbis and how they dealt with the Old Testament. But I'm using it for what they've done with the subatomic particles and their theories of how they're created and what they are. Here's another example. You get an idea of what's really going on. Here's a track they call an omega particle. It's a particle, probably a proton. All these things that are in color are not there. They weren't there at all. They were in dotted lines. And they see something here, it hits something and becomes something, and this goes off like this. And they label it, these names here you see. This is a photon, the shape of a photon. They think that comes off and created this over here. Again, like this. Photons, kaons, there was nothing here. All of a sudden they see this pattern, and then they guess, mathematically, what could have transmitted the energy from there to there. That's what's going on. Here's another example for current day. For quarks, up, down, down, a neutron. Something happens here, gets hit or whatever, and it becomes a proton. Up, down, up. They think it's a boson here. They show us a waveform. It hits something here, and this is a neutrino, comes down and comes out as an electron over here. This is mathematical magic. Here's more of the standard model. Neutron, proton, gives off an electron and an anti-neutrino. The reason I'm showing the neutrinos here is I'm going to show you some experiments done regarding neutrinos here, and also the next one on astrophysics and the energy from the sun. And it's important to understand this is a byproduct of nuclear fission. And so, he gives proton, gives off an electron, an anti-neutron, and a photon, piece of light. First neutrino was detected in 1970, Argonne National Labs, the University of Chicago. And they were trying to show beta decay. Again, something magic comes across here. See, there's nothing here. You see it. All of a sudden, they see this path, and that. Neutrino formed into a mu meson, a particle. Invisible neutrino collides with a proton. Again, this is all guesswork. Trying to save momentum and other things, and why this is happening. Again, of course, the curlicue I explained earlier, because it's going around this toroid shape. Oh, this is what I was trying to. This is why they came up with the neutrino, to beta decay, which is what I showed earlier, can conserve energy, momentum, and angular momentum. So they were faced with that, but I'm not sure that has any relevance when you have a created reality and the information is coming into this reality. Here's another example, how far they've gone. This is the quark idea. Up, down, strange, charmed, top, bottom. I don't know why they come up with strange and charmed, but leptons, and then finally Gauss boson, and this is Higgs bosons. They're hoping is going to give them their answer what gravity is. They've even come up with anti-quarks, believe it or not, made up of anti-quarks. I mean, that's the problem they're having. Anyway, I decided, okay, I'm going to go through. When I first started doing this back 41 years ago, when I did this book, Reality Revealed, there was only like about 23 subatomic particles and families. So I said, okay, let's see how many there are now. And I went through, and I started doing a table. See bosons, byrons rather, and they call them renaissance, bottom charmed, double charmed, double charmed bottom. I mean, you can see the chaos going on here. And made up, of course, quarks. Up, down, bottom, whatever. And these are all calculated mathematically. This is mathematical, magical thinking. And supposedly decays to this. Anyway, I'm going through it, and I said, this is going to take me forever. So I decided, okay, this is insane. I gave up on this stuff. I just wanted to see how many they had here and what this was all about. And this is what I came up with. They now have a total of 135 subatomic particles. Now, in there is included protons and neutrons, and I showed you a few minutes ago. They may not exist, or you got a center modulation point, and what we call it is just not right. Quarks, leptons, bosons, Byrons, mesons, light, unflavored. That was surprising. 41 exotic. I did not include the theoretical. I could add another 25 or 30 onto this. When you see this, you should know right off the bat, something's wrong with the philosophy. And I think that's maybe why about 10 plus years ago, some physicists decided to go the route of string theory. Because this stuff couldn't explain gravity. So they decided to use string theory. This is one of the patterns here. They did a Xi-CC, newly identified particle is kind of a Byron, a subatomic particle composed of 3 quarks. Yeah, right. Sure. Again, the reason why it's going in circles is it wasn't imparted with enough energy, maybe, and it's the information. These pieces of information, you don't know how many hundreds are there, are still going in this circle here. That's what's going on. At least that's the theory of multidimensional reality is saying that. But this is you see it yourself. Again, there's thousands here, tens of thousands. In lead, I think we only have, on my thing is like 250, but National Institute of Standards has 455 spectral lines for lead. This is a lot more than 455. And again, you see that curve on the whole thing. Here's more. I mean, it's just, why bother identify it? At some point you have to say, okay, I don't know what the hell's going on. And I think that's maybe what Stephen Hawking finally dawned on him. We don't know what the hell's going on in here. Okay, now to the basics. What I think these bands are. This is gold, something we all love, right? Atomic number 79, and it has 254 spectral lines that I had in my table, my Russian table. And I only did the intensities over 100. And this is what I pulled out. There was a lot more than this. I just kind of condensed it so I could fit on the screen here. This is our visible spectrum, and I think there's a couple more extra than what I have here. But some of this is arbitrary for the group that winds up determining the wavelengths or the brightness of it. But for those physicists out there, to me, this looks like it's not only pulse modulated, but amplitude modulated. And the amplitude would be the brightness of the bands. Each one of these bands has information about the atom. We just don't know what the information represents or what it does. And we don't really have to. We're very primitive. But this is some of the information. There were so many that were under 50. I mean, you know, of my 254, there was the vast majority was, you know, pretty small. But here's lead. Again, you have some pretty bright. This is actually two together. Some pretty bright ones and some faint ones. There's a faint one down here. And again, look at the intensity of some of these are great. What's the information that's in here? We don't know. This one is in the ultraviolet. This is angstrom units, nanometers. So way up here is probably this real bright one up here. So the green one's down here, maybe only measured as this. But you're seeing the point I'm getting at. This is information that makes up that atom. We just don't know what information is in these things. That's it. I'm glad I did this within my half hour. The next one, video will be on the cosmological problems that physics has had, explained with the theory of multidimensional reality. I hope you enjoyed it. I hope you got something out of it. And hopefully it will spur some research in a different direction.